Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I am part of the database organization here at Oracle. So today we're excited to show you a live demo on how to integrate Oracle Digital Assistant with the advanced search features of Oracle Database 23 AI. I'd also like to note that we are recording the webinar, and you will receive the replay via the same email that you registered with after the event concludes. If you have any questions, we've enabled the Q&A section of the Zoom and will answer throughout the hour, as well as leave some time at the end for any remaining open questions. We have Steve Nichols, Master Principal Cloud Architect, helping with Q&A, so please send your questions his way over the Q&A section. So thank you, Steve. And today's webinar will be presented by Derek Cameron, Master Principal Cloud Architect, and Saipriya Thervakadu, Principal Cloud Engineer. So without further ado, Derek, take it away.
Thanks, Tara. Welcome everybody to our presentation today. Again, joining me is Supriya and Steve. Supriya, Steve, and I all work on the Code Innovate team, and Steve will be discussing our program at the end of the webinar. So last month, I did a presentation on the advanced search features of Database 23 AI. I showed you an Apex application that integrated all the different search features. And in that presentation, I discussed and inserted that what you can do is deploy all your AI applications using the database backend as your AI hub. And specifically, I called out Digital Assistant. And so today we're going to do exactly that. We've got on our team, Supriya, who's a Digital Assistant expert. She'll be showing you a digital assistant application using this database backend as the AI hub. Of course, you can use any application. And so the whole idea is that all your database, you back that database up, you clone that database, and all the AI components are automatically copied and backed up with it. I'll be starting off by just touching on the Database 23 AI search innovations. This is a bit of a review. I'll be covering that fairly briefly, and then I'm going to pass it over to Supriya to cover Digital Assistant. She'll talk about the service. She'll provide a notional architecture, and then because we're always more hands-on focused, she'll dive quickly into an ODA application built using the functions that I created. So, and then she'll hand it back to me. I'll show you a little bit under the covers how the underlying database components are configured, show you how that works in SQL, and then we'll follow up at the end with Steve covering the Code Innovate program. So previous webinars related to these topics. It's a big topic. If we cover these in depth, probably take 2 or 3 hours. So I'd encourage you to go back to some of these previous recordings. Steve and I did a deep dive on Select AI back in February 2024. We followed up with a deep dive on vector search in August. Then in January, we revisited those two services to cover Select AI vector search, but introduced also Select AI with RAG and generative AI agents. So check out that presentation if you want to see some of the services we're covering today, but in a little bit more detail. And then lastly, just last month, I covered an Apex application that pulls all those different search techniques together and introduced Ubiquitous Search and hybrid search, which we had previously not covered. All of those are going to be covered today. The ODA application will be interacting with these database services, these AI search features and AI features. So yeah, next slide. Next slide. So yeah, Ubiquitous Search, it's new in 23 AI. It enables you to perform full text and range-based queries across multiple objects within an entire schema. If you're like me, I've been around the database for 33 years. If you wanted to do search even up to 21C, you would have to search individual tables and individual columns. The column limit on 23 AI has gone to 4,096 columns. If you need to search across all of that, practically speaking, it's really kind of impossible. With Ubiquitous Search, that's now enabled. And we have a new package. It's a DBMS Search PL SQL package, and you index tables and columns that you have select privileges on. It doesn't necessarily, it could be across different schemas. You can add data sources, remove data sources. As soon as you add a data source, the index automatically indexes the content on that, and then you can perform searches across all those tables, across all those columns, including JSON duality views. So very powerful feature. Next. Select AI. Select AI actually was introduced in 19C, and it does allow you to issue natural language questions and have the language model take the definitions of your table, which are captured in a profile, take those definitions, including comments on those views and views and columns and tables and columns, evaluate that, look at your question, generate the SQL, and optionally execute the SQL. So it's a way of providing a chat interface for a layperson to ask questions of their structured data and have the database generate the query, the model generate the query, and the database run that query to get the results back. Next. This is what it looks like. You provide the database schema metadata in a profile. The end user issues a natural language prompt. It's a conversational prompt. The prompt is augmented. It augments with some prompting preamble. The language model looks at that, generates a SQL, sends a SQL back to the database. The database then executes the SQL to give you your results. Next. AI vector search, that's another 23 specific AI feature, and it allows you to first ever provide semantic searches against your data in the database. Next. You can search documents, images, even video using vector search. The process looks like this. The user issues a question. The question is converted into a vector. The database in advance has your data chunked and vectorized. And so the database compares the vector of your question against all the vectors of the text chunks in your database, matches based on similarity, vector similarity, finds the top chunks based on that algorithm that compares the vector of the question against the vectors in your data, finds those chunks, sends the chunks to the language model. The language model reads the chunks and evaluates and interprets those results and send you that answer back in a natural language response. Next. Now, I get this all the time. People consider if they're doing a semantic search, I have to use vector search. That's not true. If you send an entire document to the language model, semantically, it does understand that content. And so often we have people building or thinking of building vectors on data. The vector search comes into play when you say, I need to search 100 documents, 1,000 documents, 10,000 documents. You can't send all that to the language model. So we need to do a query within the database to find those relevant chunks. And so we vectorize that data. We take a document, we create the chunks from the document, the chunks are vectorized. The user asks a question, we filter it, and then we send that back in a document search. And we have this in Code Innovates all the time. For example, what are the troubleshooting steps for a particular piece of equipment? There's maybe 20 steps. If you vectorize it, you get maybe 5 because the chunks are not huge. We'll just send the entire document to the language model and it'll come back with an answer. So we use them together. We use them together all the time. So Priya will show you how that works. It's not vector search. It's actually complementary to vector search. So next question or next slide. Hybrid search is, again, new in AI. I'm not going to cover it today. We're not going to be doing any hybrid search. It is covered in our last presentation last month. It combines text search with vector search. The text search comes back with a score. How often is this text or these terms in the document? How often do they occur? It comes up with a score. It does a vector search, a semantic similarity search. It comes up with a vector score. And there's a number of various strategies for combining the vector score with the text search score, combining those to come up with a more accurate response to your question. Check it out. It's got there's a number of strategies to optimize and tune your searches. Yeah, check it out. Next. So with that, I'm going to turn it over to Supriya to talk about digital assistant.
Thank you, Derek. That was a pretty good overview. So now let's talk about the Oracle Digital Assistant. What is an Oracle Digital Assistant? It is like an AI-powered text as well as voice interface. So you can pick the language of your choice. So for example, if you wanted to interact with the chatbot with the help of, like you can also talk in English or you can ask a question in Spanish and so on. So you can pick the language of your choice and it will save a ton of time, especially for your call center operations, by helping the agents to focus mostly on the important task rather than being bogged down by the mundane tasks. So you can get an answer to any question or process a request or drive an action using the digital assistant in the most natural and conversational way. So with the help of ODA, now I'll start coining the term as ODA instead of Oracle Digital Assistant. The ODA is like a low-code conversational AI platform that allows the businesses to deploy the AI assistants. So that being said, let's go on and then discuss more about what are the key components of the digital assistant platform. So these are the four important components of the digital assistant. So the first is the channel configurator. You can deploy the digital assistant in the channel of your choice. For example, you have a web application or a mobile application or even a voice assistant like Alexa. You can deploy the chatbot on any of these channels. We also have something called as dialogue flow execution. For example, when two humans talk to each other, it is kind of a complex conversation, right? You start off with a conversation, you go to a different conversation, and then come back to the original context. In this scenario, you need to make sure that you have the memory driven conversation. That means like you need to understand the context and then make sure that like every question asked by the user is being answered by the chatbot. We also have something called as enterprise data integration. What does it mean? You can deploy the chatbot and then configure it with your backend system. Here, the backend system can be like SCM system or HCM system or any third-party system in general, which has the REST endpoints enabled. And the most important aspect why we all use digital assistant is the conversational AI platform. Here we have machine learning algorithms and the natural language processing algorithms, which are baked inside the system, with which you are able to interact with the chatbot and then get the response in the most natural and conversational way just by asking simple questions or utterances from the user to the chatbot. Now, let's dive into the digital assistant. Here we have these different backend systems. For example, you have SCM, PeopleSoft, ERP, HCM, CX, or any third-party system in general. You can have the chatbot deployed on any of these conversational channels like Slack, Alexa, or something like a web channel, WhatsApp channel, and so on. Now, when I refer to as Oracle Digital Assistant, it's like a master bot which has multiple child bots together. As you can see in the slide, we have different types of chatbots here. Now, we'll start terming the chatbot as skill. So we have different skills here. So when a chatbot is asking a question, when the user is asking a question to the chatbot about submitting an expenses, it is taking you to the submit expense skill. When I ask a question about procurement, it is redirecting the conversation to the procurement skill. However, all of this information is coming from the backend system, which has the REST endpoints enabled. And you're getting this information from the ERP or HCM system and then displaying back to the user. Now that we spoke a high level overview about the digital assistant, now let's dive into what our demonstration would look like. Here is a notional architecture. Here we have picked a fictitious clinic called as care clinics. So this is a hospital and the hospital has a physicians. So the physician will be able to log into the hospital portal and then the physician notices a chat widget. And with the help of chat widget, you are able to interact with the digital assistant. So the digital assistant is connecting to the backend Oracle Autonomous 23 AI database and making use of the search capabilities of the database from the digital assistant using the REST endpoints which had been enabled by using the PLSQL functions which Derek was talking about. So he has spun up this PLSQL functions exposed using the REST endpoints. And using the REST endpoints, you're connecting from the digital assistant to the backend search service. And here we are going to use the Node.js container. So the Node.js container is like an embedded container within the Oracle Digital Assistant platform itself. And from here, you're invoking the database REST endpoints from the digital assistant, and then you're getting back the information from the backend. So as you can see here, the ODA is now powered with the vector search, document search, image search, and so on. Like you can name it, you can connect to the API and then get back the response using the REST APIs. So what exactly is happening here? The physician is asking a question in the natural language, and this question is turned into vector. Vectors are like those chunks which Derek was talking about. And you are sending this vectors to the AI vector search. And this question is turned into like vectors and then sent to AI vector search. And the AI looks into matching documents or the content stored in the private database. So it finds the most relevant information from this backend, and then it is passing as argument. So the argument will contain these three things. One is the user question, you have the content, and also the general knowledge information. By using the Gen AI model, it queries this information and then gets back the clear and helpful response, which is readable, which is user readable by the physician. Here, let's go into the step-by-step process about like how we are building the digital assistant and how we are connecting to the autonomous database 23 AI search capabilities. So before that, I thought, why don't I show a quick demonstration and then talk about how we are building this chatbot together. So in this entire demonstration, we are going to focus more on the ODA capabilities, whereas like we'll after we showcase this demonstration, I'll pass it back to Derek, and he will show you how he has configured all the PLSQL functions in the backend in order for the ODA to consume. So that being said, I'm going to move on to my screen where I've configured the chatbot. Here, when a physician is logging into the portal, he is able to see the physician portal with a small chat widget on the right. So when you click on the chat widget, it's going to respond saying, "Hello, I'm your AI-powered research assistant." What we have done here is that we have loaded a ton of the white papers, and the chatbot, instead of like you as a physician going into the database, checking every document, reading through every document, and getting the information from of these white papers back to the user. Instead of doing all of this, we are just using a chat widget, interacting with the chatbot, getting this responses, summarizing huge white papers, and then getting back the responses. So let me do one thing. I'm going to be the physician now and then start asking the questions. So let's say here I'm going to select search based on the image. So let me click on this and then I'm going to upload an image here. Here, let's say I want to search something related to Neuralink. And then what is happening in the background is that it's actually calling the Vision API, the Meta Vision Instruct model, and then it is querying the image and getting back the response. Here, this image is related to Neuralink. So it is going to say that the image depicts Neuralink. And then after getting this information, so this is the prompt, right? So after you get back this Neuralink information, you're calling the backend system, that is your vector search API. And the vector search API is now going through all of the white papers and then get back the response. So as you can see here, the Neuralink Neuralink is integrated brain machine interface platform and so on. So all of this is very neatly written down here and it is giving back this information back into the chatbot. So let's say I have some more questions, right? So let me do one thing. I wanted to search across all the white papers and get the information. Here, probably I might want to check the statistics of people undergoing loneliness. So let's say I'm going to type in this information and then let's see, it's asking me to pick a category. Either I can pick a medical category. Here, I wanted to see more of statistics and information. So I'm going to select the health statistics. But where am I getting all of this information from? So I have loaded all these PDFs into the database. Derek has helped load all of these PDFs, and for the sake of simplicity, we are showing this in the Apex. This is the Apex page, the web page, and here, like when you click on each of these PDFs, you can see. The information. These are all the white papers. So this is like a 14-page long white paper, and there are like ton of white papers we have loaded for the purpose of this demonstration. Here, as soon as I asked for the health statistics, it is going up and then converting the natural language and then converting it into SQL. It is converting the NLP to SQL and then it is getting the average response from the backend or in the tables which we have loaded and then getting back the information back to the user. So let's say probably I don't want to see more information on this and I have another question. Here, I also want to check what studies have looked at using the internet to improve the health outcomes. So let's say I'm going to type out this question and then I'm going to select probably here the category is medical, and then I'm going to select this and then see what information I get back. The first response you're seeing is using image search. The second response you're seeing is using the natural language to SQL conversion. And all this is happening in the background. All you're seeing is the data back, but you're not seeing the complexity which is happening in the background. So this is the information I got related to the studies that have looked at for the internet from the internet to improve the health outcomes, and this is all information coming from your white papers. So let's say I want to see specific information around Oregon. So I want to see more information about Oregon. Probably I'll use that as a keyword in order to search. So in this data which we got back, here the Pure Internet and American Life Project. So this is from Oregon. So let's see if we are getting the same information back to the user or not. So now you can see that the Pure Internet and American Life Projects published a study in 2000, and all of this information is all being captured from the backend, and you can see it in just a few seconds. All right. Now, let me just summarize and then see a specific white paper, right? So I have a ton of white papers here, but I don't want to read all of these white papers. It's a lot of information, right? So what we can do here is that probably I'm going to summarize a white paper, and probably I'm going to type in the question saying, um, probably I want to check about the e-health literacy scale, right? So what is the primary purpose of e-health literacy scale? So this is our prompt. And this is found in this document called JMIR E27. And I want them to go through this content, check the document, and perform a document search and summarize this information and then get back the response. So let's see. Here, all of this processing is happening. As you can see, it is loading information. And here you go. The primary purpose of e-heals, that is the e-health literacy scale, is all of this, right? So now we have performed different types of search techniques. One is NLP to SQL, and then we did like vector search, document search, and also image search. So now that we saw how the demo looks like, let's see how we are configuring this from the backend. How are we configuring the Oracle Digital Assistant? So when you log into the Oracle Digital Assistant portal, it's going to look something like this. So when I log into Oracle Digital Assistant, I can see all of the demonstrations, which are all the skills which I have. I can go into each of these skills and then look up for more information. Here, what I'm really interested in is that like I wanted to check the chatbot, which I have configured right now. So this is our chatbot which we have configured. The first thing which we need to create is the intents. So intents are nothing but the intention of the user, right? So we need to capture some of the user intentions. For example, I want to search based on an image, like search, upload an image. So these are all the utterances which we are passing. Whether you want to search a specific white paper or you want to check all the white papers, right? So all of this utterances, you are going to type it out here. And then the entities, you're going to configure the entities if need be. And then you're going to also configure the dialog flow. So the dialog flow is the dialog flow execution, which we were talking about in the past. Here, let's say I'm going to pick a specific flow. For example, let me type out hi, and then it is going to take me to the greetings flow where it is showing me a menu. So this is a menu. So I'm going to show a menu to you guys. And then I want to search across all the white papers. Correct? So here, what is happening is we are going to the vector search flow. And these are all called as states. And we are going to a specific state to get back the information. So if you ask a keyword, let's say if I want to check the studies, what studies have been looked at for improving the health outcomes. And here it is setting the prompt, and you can see how the variables have been configured here. So when I said like what studies have looked at using the internet to improve the health outcomes, so this variable has the prompt, and the prompt variable is automatically being captured here. And then here I'm going to select medical, so that's the category, and this is the domain name which I'm passing it to the API. So let's see what's happening here. So the interface which I'm showing you is um, is the conversation tester. So it gives you a way for you to test the conversation and make sure that like if there are any errors or anything like that, it's very easy for you to debug. So this is capturing the information from the API and then getting back the response. As I mentioned, we are using something called as a custom component. So let's see how we are configuring, let's say, vector search flow. Here, we are going to start off a conversation saying that, like, sure, I can help you with that. And then you're setting a prompt, what are you looking for? And then capturing the variable called as prompt. And then setting the domain value. And you're giving an option saying, like, whether it is health stats or like medical information. And then you're configuring the vector component. So this is the custom component which I was talking about. So the custom component is the vector search, and the way we configure the custom component is from here. Like when you click on the custom component and you can like add your own service. Here we are configuring something called as embedded container, and you can either create a new component here, or you can, this is all like leveraging the Oracle Web SDK, Oracle Bots SDK. And with the help of Bots SDK, you can create the Node.js component. I have already created the component here, and so this is what it's going to look like. The vector search component has like the three variables. One is the prompt, which I'm passing it from the user to the backend, and the domain, that is like the domain value, whether it is medical or health stats, right? So these are the two domain values you're going to pass as an input to the backend custom component. And then, so this is like the section which you see here. This is the input. That is whatever information you're sending it from the chatbot to the backend system is all captured in the input. And this is the output section wherein you're going to invoke this custom component. So this is the API which I want to invoke. In the API, so this is the API which was being exposed by Derek. He has created like the vector search API. And in that vector search, you're passing the prompt as well as domain value. And all of this information has been captured. You're calling the API using the get method, and then you're passing the headers and so on. It's very simple. It's very similar to your Node.js code which you configure, but it's quite simple when you continue to create the custom components. And in the search, let me do one thing. Let me just go ahead and then probably just search based on the API itself. I'm going to type in this API and see what the response I get. So this is the API response. And the API response, I need to capture the first part of the API, that is AI search. And this is the information I need to capture from the API and then show it back to the user, correct? So for that, what I'm doing is I'm going into the API and then capturing the AI search within the JSON response. And that response is set as a variable as a vector result, right? So let me go back and then show you what's happening here. Um, so when I click on the preview button, the vector search result is captured from the backend, and this is the response which you're seeing here. Yeah, this might be a lot of information, but then if you like, if you have a program like Code Innovate, you can work with us, and then we can help you at least showcase you how you can build this together and put a use case together using the Code Innovate program, which Steve is going to talk about at the end. All right. So now that we have created this digital assistant, I wanted to show how we can create something like a document search flow so that you have a little bit more idea of how you can configure the custom component and how you can configure the flow for the digital assistant. So let me go ahead and then probably show you a quick demonstration. Here, you have the intents, right? So intents is like here we are going to create a flow for searching all the white papers, searching a specific white paper, right? So for that, we have written down some intents. But let's go ahead and create a flow for this, right? So let's click on the plus add flow, and then I'm going to type in document search. Here, I'm going to select the search specific white paper. So whenever somebody says, I want to search or summarize a specific white paper, I'm going to I'm going to take them to this particular flow. And here, I'm going to first start off by creating, like asking the user, giving an assurance to the user that like, hey, I can help you with that, right? So for that, what I need to do is click on add start state and then say for example, start doc search. So this is the flow I'm going to create. And then here I'm going to say, sure, I can help you with that. Okay, so let's see what happens. Let's say hi. But then here we are just showing search across all the white papers or search based on an image, but we do not have something called as searching based on specific white paper. So for that, let's go into the greetings flow, and we observe that we haven't written down the search specific white paper. So I'm going to copy this and then paste it here. So here I'm going to type in doc search. Let's say the action is doc search, and then I'm going to say search a specific white paper. And when I do this, I need to also invoke a specific flow. I'm going to create a flow for, yeah, I've already created a flow for a document search. So I'm just going to write in um, doc search, and then I'm going to pick I'm going to create a flow to invoke the document search. So I'm going to type in invoke flow, and then going to type in um, document search. So this way I'm able to invoke the flow. Let's see the difference now. So now when I say hi, it's going to respond, search across all white papers, or you can search for a specific white paper and search a specific white paper. And then it says, sure, I can help you with that. But we haven't configured anything else after that, right? So what we can do is we can go ahead and then click on add state, and then you can set the prompt, right? Let's say I want to ask a question, and then I can set the prompt. And here I can create a variable called as prompt, because I need to capture the prompt from the user. And then I can set a variable as string and then click on save. So next question is that you're going to ask like, what are you looking for? And after that, I've also configured the API service, right? So if I wanted to get the list of files, I can create like an API service here. That is like, let's say I've created a REST API. And in this REST API here, this is the 23 AI list API. And then when I click on the test request, you can see that these are all the API responses. And it is creating like an array called as items. And in that you have file name, file one, file two, and so on. And you can see the list of files. So you want to display these files as a button and back to the user. For that, I'll go back to my skill where I've configured. So in the home, I'll see the most recent skill, so it's easy for me to pick. And then I'm going to go to the document search, and then I'm going to add another state to call the REST service. Here, I'm going to select search 23 AI service, and this is a get method. And then in here, I'm going to like save this response in a specific variable. Here, I'm going to create like a variable called as files, and I'm going to create a map flow so that like all the JSON response is being copied into the call REST service, the files component. And after I do that, what I'm doing here is that I'm going to also set the domain. I'm going to add a state to set the domain. Let's say I want to create something like an action menu button, and then I'm going to ask the user to pick from the domain name. So even if you do not follow every step, but I just want you to get an idea about how everything works together and how easily you can put this component together, how you can create the flow within no time. So here you're creating like a button list with the list of components. Now let's see what the difference is. Um, I'm going to do the same thing again, and I'm going to select search a specific white paper, and now it's asking, what are you looking for? Probably let me ask a question. I'm looking for a brain machine interface. And then it's now going to ask you with the list of documents. So till now, we did not have this flow. However, after calling the API, it's pulling in all the information of these file names and then presenting it back to the user. And after we do that, what we are doing here is that like we have configured the next is we need to call the custom component. So here I'm going to type in custom component, and then you're going to call the custom component here. In this custom component, I'm going to search for document search custom component, and then I'm going to pass the vector search variable, vector result variable. Let's say this is the document name. Here you can configure like your own variables here. For example, I can create like a document name, and then you can save it, and then you can create more variables. So with the interest of time, I will go back to the original flow where we had, and then show you how we have actually configured the document search flow. Um, So this is our flow, and this is the same exact flow which I was talking about. And then here is your vector search component, and then we configured the variable called as document name, vector result, and the files. And here we are calling the custom component and passing the vector result, document, and prompt. So these are the three components which are required, and this is what has been getting passed to your backend custom component. So let's go to your document search. So this is the document search. You're passing the vector result, file name, and the prompt. And the prompt and the file name is passed into the URL. And then you're getting back the response. And this response is stored in the chat document. And this is the vector result value, which is being set back into the bot. And you would then present the vector result. So the vector results which you're getting back from the backend system, you're presenting it back to the user. And then you're going to exit the flow. So if the user has more questions, or if they wanted to search any other white paper, you're going to ask the user saying that, is there anything else I can help you with? And then you're presenting again the menu so that like the user can pick from the menu or type in any other question which they have. So that being said, I believe you guys got a high level overview about how you can create a chatbot, build the flow, as well as configure the custom component. Now I'll pass it back to Derek, and he will walk you guys through how we have configured these functions together.
Great, thanks, Supriya. Let me share my screen. Yeah, so this is the database backend. Again, I covered this somewhat last month. If you've seen that, this is a bit of a review. We've had several questions. Hey, can we do this on Apex? Yes. If you look at the recording from last month, all the entire flow is Apex. Today's focus was, hey, it doesn't have to be Apex. It can be any client, any chat client you would like it to be. It can be embedded in your transactional applications as well. The whole point being is that your data is already in the database. Your transactions are getting processed there. Why not put the AI there as well? So, and then use whatever client front end you want, Node.js, non-Oracle, pick your service. So yeah, let's go through this. And a lot of this is just design choices on my part. I created something called a domains table. Why did I do that? Because I wanted users to just tell me what they wanted to ask questions and what data source, and depending on the data source, route it to the right PL SQL function, which you see in the lower left. And so this table does that. I'm working just last week with a customer that has different equipment lines. We use domain to narrow down to the line of equipment, and then within that, the different pieces of equipment. So domain's one of these things that you can use in a variety of ways. It was just a choice I made to be able to subset and filter data based on what it is you wanted to ask a question of. We have medical images. I have health stats. Supriya went against the health stats, as well as the medical data, because medical documents. Here's the documents. This is the documents, and I downloaded a bunch of internet documents, GMIR documents, or research documents. When I loaded them in here, I have a trigger on this table. I have a trigger that kicks off a job that creates the CLOB. You'll see the CLOB on the right-hand side. You can see the domain, and you can see I have other domains in here. So we're doing our presentation on the medical use case here. So I filter on that. It could be HR, POs, PeopleSoft. Someone had a question. Can we do this against PeopleSoft? Yes, we can do this. It's all data, right? It's database tables. You may have to extract it out of your source table if it's not 23 AI, if you want to do this. We've also done events across database links hitting remote databases too. So think about that. And some of this is not English. I had a sales consultant ask me, they gave me a Italian document and it had handwritten Italian in it. I don't know what to do. Let's upload it to the AI service, let it translate. It was amazing. So I uploaded an Italian research document, which I'll show you as well. So there's the documents. Of course, I talked about chunking. Every document is multiple pages. You can see the size of some of these, some of them almost over a megabyte, 8 MB. And so we chunk them, and the chunks are created off the trigger. And you can see, remember, I talked about the chunks and then the chunks having vectors. There's the vector column right there. We have a document vector table. I've chosen to track conversations and conversation prompts. And why? Because you can have multiple concurrent conversations and you might be doing follow-up questions. Well, if you don't track your conversations, then you don't know who it is that's talking. So you do need to maintain information about the conversations and within that, the questions they ask. You can see the conversation ID here, the prompt, which is the question, right? I've got COVID questions, all kinds of different questions in here. You can go back and analyze it. Back end, like the IT people can look and see what is being asked. How are the questions coming back? Well, there's the response. And there's a whole bunch of stuff in here I'm not going to go into. The responses come back as JSON. We store all of the gory detail, the domain, the AI service that's used, document search, vector search, natural language to SQL, image search. All of that's maintained in here. And by the way, this schema search 23 AI, people have asked like, hey, I want to put this on my environment. Steve put together a workshop, a Git repository. It's a whole workshop set of steps. All of the back end can be reproduced on your environment by following the steps. You just need a database, an autonomous database, and all the steps to configure that with AI are in there. I suggest you go back and take a look at that. And again, that was from last month, and it did use the Apex app. So whether you use Apex, Digital Assistant, Azure, whatever, if you use these REST endpoints, all of this conversational history is tracked and consolidated in these tables. So you can be maintaining all of that across your infrastructure. Prompts, the AI search is a wrapper package because if they're asking vector, the domain is a vector search. I issue this function. If it's not, it's natural language SQL, I issue this. So it's a wrapper function. Similarly, document search is a wrapper function. Am I asking about text or am I asking a question about imagery? And so it routes it to a document single or an image search function. It's all just PL SQL. There's the natural language. It's just issuing down here, DBMS Cloud AI Generate. You can manually do that too, but I've wrapped it around. So I have conversational history. If I just issue this command, of course, that's not captured. And then probably the key function across all of this content is in this function. You'll notice I just changed this last week to uptake the new cohere command that just came out. This is the one I've been using. This is the one I'm using now, moving forward. So I can just change the model right here in the and this could, of course, be exposed in a table as well. I just didn't do that. And similarly, for a detailed document search, like send the whole document, I have uptaken, again, just last week, the new Maverick Llama 4 model. I just commented out my old one. I've added the new one, and the rest of it just works. I've got some views because it's all JSON. I want to be able to see it in Apex or anywhere else. Supriya uses as well citations. We have a citation REST endpoint. It's all JSON, but it flattens it out as rows in a column, in a table, citations, ranking. There's the package for creating, as I add a new document, creates the chunks and the vectors. It's all on a trigger. Don't have to do anything. You just load the document through object storage or through your Apex app, does everything in the background. And then again, these functions right there. Let me just touch on a couple of things here. I just want to show you this. This is the Italian document that I loaded. I don't know Italian. Do you know Italian? Somebody here probably does. But I started asking questions. I said, hey, this is Italian. Could you just summarize it? Give me the key points, this Italian document. And it's all coexisting with the other ones. It's not another database. It's just another row in the table. The other really, really interesting thing I did was out of one of these documents, I literally extracted this image with the text. It's a PNG. I said, hey, explain this. I'm reading it. I'm not sure I understand. It read the narrative in here. It looked at the document. It looked at the diagram and it interpreted it. And by the way, the new Cohere model supports some domains like finance, manufacturing, I think another one in here. So it does have some and healthcare actually is one of them. It has some domain expertise. That is, the language models are general purpose, but the newer ones do have domain specific knowledge. So pretty interesting. Let's go to some of the questions. Natural language SQL. To save time, I will not execute these. There's my question. Compare different indicators for those that may be lonely. Runs through, generates this. This is the SQL. There's the response in rows. And then here is the narrative explanation of the data that's come back. I did a vector search. What health interventions are effective at reducing stress, depression, anxiety? This is a vector search. There's the chunks. You'll notice 571, 579. These are the documents it got it from. There's the answer. It comes back JSON. We translate that. Don't worry. You can pull all this if you install the workshop. We flattened all this data coming out of the JSON, but that's what it actually looks like. There's the documents search. Again, this is just a repeat in SQL of what Supriya is doing. That's all we're doing here, a repeat of what she's doing, but in SQL. And then summarize and translate from the Italian Journal of Medicine. That was that PDF I showed you in Italian. Well, this is its response. This study is written in Italian. It can derive the language. And the Code Innovate we did last week, they have support people all over the world. They'll be able to use AI to do that translation and answer questions in multiple language through a one single application. So yeah, discusses blah, blah, blah. You can read that, but it's all translating and interpreting and summarizing in one question. There's the image search. Remember that diagram I showed you? Here's it. This diagram illustrates the positive interactions between various symptoms experienced by electronic cigarettes, blah, blah, blah. The diagram shows there are several symptoms that are closely related to each other, such as, I'm pretty blown away myself by this, given that I'm reading it, trying to understand it. It's using its knowledge, its healthcare knowledge on the latest model and translating this as well. We've done healthcare events with hospitals, with doctors, physicians. Amazing. There's the overall conclusion just based on my question. What does this diagram show? There's the image that it comes back. We do have a combination of vector search with ubiquitous search. There's the answer. The whole point I did this is returning results across multiple documents that were authored all over the country And I'm saying, well, I live in just Washington State, but OHSU Health Sciences Research is right across the bridge from me. And it's like, I just want to direct my question to documents authored in Oregon. And so I do a keyword. I only want Oregon docs. And so now it's come back with the one document authored up the street, up the road from me. And here's the rest calls. Supriya's been using these. So I don't need to execute them. I can put them in a browser, but I did clone my database, and the only thing I needed to change was the name of the database in the URL, and there it is there. I didn't add the credentials. The data's there, the functions, PL SQL there, the credentials, as I said. Even the REST endpoints are there. The only thing I needed to do was clone it. Took less than 10 minutes. It could be in another region, and I changed the database name, and it all just works. Automatically backed up, blah, blah, blah. So yeah, pretty interesting. With that, I know we're coming up on the top of the hour. Steve, I'll turn it over to you to talk about our Code Innovate. This is where we get a lot of these interesting use
Great. Thank you, Derek and Supriya. I'm just going to take a couple minutes here and share the Code Innovate program. Derek and Supriya referenced it several times throughout today's webinar. What is a Code Innovate? Simply put, it's an experience where we work with customers hands-on on their use case. And so the first part of a Code Innovate is identifying work cases or use cases that a customer wants to work on. Today's use cases would be around vector search, select AI, ODA, but we do cover other services as well. The key with a Code Innovate is it's hands-on experience with the services. Uh, you're building in your own environment with your own engineers or builders, and Oracle engineers are guiding you along the way. And then at the end of our week, Code Innovate is a week-long experience, 4 hours a day, so that's 20 hours 1 week. The goal is to have a first pass prototype or a minimum viable product built at the end of that time spent. And so uh, simply put, a Code Innovate is a hands-on experience with OCI cloud services. Um, the event itself is 1 week. It takes place in the same week, Monday through Friday. It's 4 hours a day. Our engineers work alongside your team and assist your team in building out a first pass prototype. The cool thing is it gets hands-on experience really quick, really fast, allows us to share our knowledge with you. It's also important that we leverage your use cases. We just don't want to go through a workshop for the sake of a workshop. We want you to work on something that's relevant and makes sense for your business and requirements. And that's why we ask for you to supply your use cases. Um, there's no cost for our services, meaning the engineering time that we provide for the Code Innovate is there's no cost associated with that. There are costs associated with the services that you would use in your OCI tenancy, but our time as engineers, there's no cost associated with that. The requirements at a minimum are we ask for 4 developers from your team. We use the term developers, but that could be a builder in the sake of an OAC report, Oracle Analytics Cloud. You're not developing something, but you're building reports out. So, four developers. We ask for a commitment of 4 hours a day for 5 consecutive days in the same week. We also ask for your use cases, so you have to supply a use case. We work through the process of determining if your use case is something we can support, and if it is, then we move forward. And then there's a lead time, 3 week minimum lead time, depending on the services and the engineering resources needed. Some are more popular than others, especially around the vector search AI. So sometimes that lead time can stretch out to 5 weeks. But those are the core requirements that we ask when you reach out to us for a potential Code Innovate. Uh, our email address is in the upper left-hand corner. You can email us at that email address with your name, name of your company, the description of your use case, and then we would work with you to determine if we could support that. Uh, Now, the timeline of what a code innovate looks like is, once we start engaging on use cases and we determine it's a good fit, and then we ask for you all to select a date, a week that you want that event to take place in, uh, and then we work backwards throughout the lead time. We'll make sure that pre-event that the environment's set up. So if you're new to a service, uh, say Oracle Autonomous Database, we'll want to make sure that that's provisioned and set up. We also like to do what's called structured learnings. We like to introduce and give you a baseline awareness of the services that you plan to use and touch the week of the event, so that you have some working knowledge. Tenancy configuration as well. Again, just want to make sure that the services are spun up, the people who are participating in the Code Innovate have access, and so that we can get into the fun part of building and not necessarily the back end service creation. And then the last box just represents the Code Innovate week itself. So that's what a Code Innovate is. Thank you very much for attending, and I'll turn it back over to, I think, Tara for a wrap up.
Thank you, everyone, and we hope to see you at the next one.